So hello guys, so welcome back to this amazing Python learning journey. Today is day 36 of our 100 days of Python, which the goal and objective is to learn and master Python over the next 100 days. We are on our sixth course, which is joining data with the Pandas library in Python. So we are trying to master the skills of joining 2, 3, 4 or more tables together using left join, right join, full outer join, inner join. There's also something called self join, where you actually join a table to itself. There's also anti-join, which is used for filtering. There's also semi-join also. So there are a lot of different joins types. So if you're familiar with joins in when you're building the data model in Excel, Power BI, or even SQL, you're very familiar with SQL because joins is a very, very popular and complex topic while trying to master SQL rather. You get it now. So we're actually looking at joins also in Python. So we're on the course called, or let me just start sharing my screen like that. We're on a course called Joining Data with Pandas in Python. We're actually using the DataCamp platform as you already know so far. So we started all the way from day one, which is from Python basics. We've been able to go this far, which is joining data with Pandas. So we started this journey data with Pandas on day 31, 32, 33, 34, 35, and till today 36. And this particular course contains 4 chapters, you can see. So we've completed chapter 1 and 2. We're on chapter 3. And we already started chapter 3 on day 35, which is filtering joins, where we learned about anti-join and semi-join. So you can catch all of that on the previous live stream. Also, do well to support this channel by hitting that subscribe button, give the video a thumbs up, and let me know your thoughts or your Python experience or trying to become a data analyst or data scientist or getting into tech, the struggles and challenges in the comment section. I'll be happy to share some tips and tricks with you to help you navigate the learning journey also. So I started trying to learn and upskill. I'm also a freelancer on the Upwork platform. So on the Upwork platform, I also use some other platforms to search for jobs and land client also. So if I'm not live streaming or learning something, I'm working on some cool projects here and there, or still trying to look for job. And I'm sharing some of my uh journey also, how I search and look for jobs and optimize this lifestyle as a freelancer working from home. I bet most people are already on their 9 to 5 job right now. So I'll just continue from here. Also, I have my data sets. The data set we'll be using throughout this journey data at Pandas. You can see these are the data sets. I already link it. There's a link under the YouTube description. It contains all these data sets, so you can use to practice all the way from chapter 1 and chapter 2 that we've done so far. So without any other introduction, let's continue on this concatenating data frames together vertically. Let's see what we need to learn here. If you can complete this section today, let's see. All right.
Hello there. In this lesson, we'll talk about how to connect two tables vertically. So far in this course, we have only discussed how to merge two tables, which mainly grows them horizontally. But what if you want to grow them vertically? We can use the concat method to concatenate or stick tables together, vertically or horizontally. But in this lesson, we'll focus on vertical concatenation. Often, data of different periods of time will come in multiple tables, but if we want to analyze it together, we'll need to combine them into one. Here are 3 separate tables of invoice data from our streaming service. Notice the column headers are the same. The separate tables are named INV underscore Jan through March. We can pass a list of table names into the pandas.concat method to combine the tables. They are combined in the order they are passed in. To concatenate vertically, the axis argument should be set to 0, but 0 is the default, so we don't need to explicitly write this. The result is a vertically combined table. Notice each table's index value was retained. If the index contains no valuable information, then we can ignore it in the concat method by setting the ignore index to true. The result is that the index will go from 0 to n minus 1. Now, Suppose we wanted to associate specific keys with each of the pieces of our three original tables. We can provide a list of labels to the keys argument. Make sure that the ignore index argument is false, since you cannot add a key and ignore the index at the same time. This results in a table with a multi-index with a label on the first level. What if we need to combine tables that have different column names? The invoice Feb table now has a column added for billing country. The concat method by default will include all of the columns in the different tables it is combining. The sort argument, if true, will alphabetically sort the different column names in the result. We can see in the results that the billing country for January invoices is NAN. However, there are values for the February invoices. If we only want the matching columns between tables, we can set the join argument to inner. Its default value is equal to outer, which is why concat by default will include all of the columns. Additionally, the sort argument has no effect when join equals inner. The order of the columns will be the same as the input tables. Now, the billing country column is gone, and we're only left with the columns the tables have in common. With that, let's get some practice in.
Okay, so let's practice and see how we can join two tables together vertically or horizontally. But this course is only looking at joining these tables together or vertically. So let me see if I have access to this data set: track master, track right, tracks right, and tracks xt that we can also use to perform these joins. Yeah, let's see. Oh, so I don't have access to these data sets in this lesson. This is not fair. This is not fair. That means I'll just perform these joins on this DataCamp interface alone. So it says concatenation basics. So you have been given a few tables of data with musical track info for different albums from the metal band Metallica. So the track info comes from their right. So the track info comes from their right. The Lightning, Master of Puppets, and Set Anger albums. Okay, the track info comes from these albums. Try various features of the concat method by concatenating the tables vertically together in different ways. So we're going to try different methods. So the tables track master, tracks ride, and track st, and that should be referring to one of the names there I've been loaded for you. So we have access to these three tables already on this interface. So just go ahead and follow the instruction to solve the challenge. Okay, let's see. So concatenate track master and track rights and track st in that order, setting sort to 2. Okay, sort is already set to 2. So we're going to sort it alphabetically like that. So let's see. I'll just mention the table names. It's as easy as that. It's going to be tracks from albums. So we're going to be using the data frame tracks from album. So pd.concat. This has to mention 3 tables. I'm going to introduce this square brackets, comma, and then track st, track st, comma, then this, okay. Oh, in that order, I have to make sure this tracks right comes second. It's going to be second. Then sort is going to be 2. So let's see. We can see the results here. Oh, let me see if I can bring this a little bit up. Okay, this is better. So you can see the results. The AID, the composer, the gear ID, MC ID, then the name of the track. Let me just switch on my camera there real quick. the name of the track, the TID, and the price, probably the price. So we just combine three tables together into vertically. So let's submit and see. So we got that. So concatenate track master and track slide and track SA, where the index goes from 0 to n minus 1. Is that going to ignore the index? Index goes from 0 to n minus 1. Let's see how to do that. Okay. I will just, I may as well just copy all of this and just say track master. We can just get rid of this and statements here. Then the index goes, I think we're going to ignore index or set the ignore index syntax to let's do it first. I'm going to say ignore index, ignore underscore index method will be set to true. Let's see if this is going to work. Voila, okay. Let's submit and see. So we are going to, if you want to set where the index goes from 0 to n minus 1, you're going to set the index argument to 2. So the last one says concatenate these three tables, showing only columns that are in all tables. Showing columns that are in all tables. Oh, that should be showing all columns that are in all tables. That should be an inner join. Okay, let's see. Just copy this. We're going to use an inner join. It's going to be inner join. Join is going to be inner. Join clause here is going to be inner. Let's run the code. Showing all only columns that are in all table. So we're only looking at columns that are similar to what we can see. So in this instance now we don't have access to this name column. Okay, we have access to the name column. A column is missing here. Let me just show you that real quick there in a better view. This is our latest this line of code. This latest one, this is it here. So we have AID, GID, MTID, name TID, and price. Why the previous records? You see this composer is there, so we don't have a composer. And that a lot of missing data are showing in this composer column. So it is not part of this column here. So the composer column is not part of the three tables. This is you get it now. So that's what this inner join is doing for us there. It's only returning records, columns that are common to both or to the three tables. Let's submit that. Great job. So you've concatenated your first set of tables, adjusted the index, and altered the columns shown in the inputs. So the dot concat method is a very flexible tool that is useful for combining data into new data sets. Interesting. So let's solve the next challenge, which is concatenating with keys. So the leadership of the music streaming company has come to you and asks you for assistance in analyzing sales for a recent business quarter. They would like to know which month in the quarter saw the highest average invoice total. You have been given three tables with invoice data named invoice July, August, and September. Concatenate these tables into one to create a graph of the average monthly invoice. So we want to create a graph of the average monthly invoice. Okay. So I don't have access to all those data sets in this lesson. So I just make use of their interface to solve the challenge. So the instruction says concatenate the three tables vertically in order with oldest month first. Oldest month for okay, it's going to be July, August, September. I'm going to be using these three as keys. so that it's going to show us which month that row of data is coming from. So let's do it like this. So it's going to be these three tables: invoice July, August, and September. So I'm just going to using the square brackets and get rid of this and here. So the keys are going to be uh, August, September, July, August, and September. The key record there. Same thing, since I'm mentioning more than 3 keys there, I'm going to wrap it in square bracket also. So this is our first line of code with the key. Use the .arg method to find the average of the total column from the grouped invoice. We're going to group this together, group the invoice by index keys and find average of the total column. So average invoice by month is going to be invoice July to September, this data frame here. Then the group by level equals to 0, then aggregate. So we're going to aggregate and say the total, that should be sum. Use the sum functions there. So create a bar chart of average invoice by month, a bar chart, bar plot of average invoice by month. So to create a bar chart, we're going to use it's a average, create a bar chart of average invoice by month. So it's going to be average invoice by month, which is this dot. So it's going to be dot plots. Going to use dot plots, open brackets. The kind is going to be our bar. Equals to bar. So let's run the code and see first what I can see. So average invoice by months. So I can also design the bar charts to different color, but let's just keep it simple like this. So average invoice by month dot plot. Then we mention the bar one. Let's submit the answer. You can see the average invoice by month. The highest is almost probably the month of August. Let's submit and see. Ooh, did you take the mean of the total? Oh, I'm supposed to take the mean. Okay, average. Oh, that's my mistake. So average is supposed to be mean. Average by month. So it's going to be mean here. I was doing some there. Let's run the code again. Well, so it's supposed to be the mean. So the highest month should be the month of September. Which month in the quarter saw the highest average invoice total? So the highest is the month of September according to the mean average. Let's see. Way to come to. So there are many ways to write code for this task. However, concatenating the tables with a key provides a hierarchical index that can be used for grouping. So once grouped, you can average the groups and create plots. We're able to find out that September had the highest average invoice total. I said it, so September had the highest invoice total. Oh, so we've been learning for the past over 136 days. Let's solve this last challenge and see what we have here. Verify integrity of your data. Probably want to verify the integrity of your data, validating a merge, concatenate and merge to find common songs. So let's solve this.
Welcome back. In this lesson, we'll talk about verifying the integrity of our data. Both the merge and concat methods have special features that allow us to verify the structure of our data. When merging two tables, we might expect the tables to have a one-to-one relationship. However, one of the columns we are merging on may have a duplicated value, which will turn the relationship into a one-to-many. When concatenating tables vertically, we might unintentionally create duplicate records if a record exists in both tables. The validate and verify integrity arguments of the merge and concat methods, respectively, will allow us to verify the data. Let's start with the merge method. If we provide the validate argument one of these key strings, it will validate the relationship between the tables. For example, if we specify we want a one-to-one relationship, but it turns out the relationship is not one-to-one, then an error is raised. Let's try it out. In this example, we want to merge these two tables on the column TID. Again, our data is from our musical service. The first table is named tracks, and the second table is called specs for the technical specification of each track. Each track should have one set of specifications, so this should be a one-to-one merge. However, notice that the specs table has two rows with a TID value equal to 2. Therefore, merging these tables now becomes unintentionally a one-to-many relationship. Let's merge the two tables with the tracks table on the left and spec on the right. Additionally, let's set the validate argument equal to 1-to-1. In the result, a merge error is raised. Python then tells us that the right table has duplicates, so it is not a one-to-one merge. We know that we should handle those duplicates properly before merging. Now, we'll merge album information with the tracks table. For every album, there are multiple tracks, so this should be a one-to-many relationship. When we set the validate argument to one-to-many, no error is raised. Let's now talk about the concat method. It has an argument, verify integrity, which by default is false. However, if set to true, it will check if there are duplicate values in the index and raise an error if there are. It will only check the index values and not the columns. To try out this feature, we will attempt to concatenate these two tables. They are the February and March invoice data shown in the previous video. However, both tables were modified so the index contains invoice IDs. Notice that the invoice ID number 9 is in both tables. Let's try to concatenate the two tables together with the verify integrity argument set to true. The concat method raises a value error stating that the indexes have overlapping values. Now, let's try to concatenate the two tables again with the verify integrity set to the default value of false. The concat method now returns a combined table with the invoice ID 9 repeated twice. Often, our data is not clean, and it may not always be evident if the data has the expected structure. Therefore, verifying this structure is useful, saving us from having a mean skewed by duplicate values or creating inaccurate plots. If you receive a merge error or a value error, you can fix the incorrect data or drop duplicate rows. In general, you should look to correct the issue. Time for some practice.
Okay, so let's see what we need to do here. This validation emerged. So you have been given two tables, artists and albums. Merge them using the artist.merge albums on artist id.add, adjusting the validate argument to determine which statement is false. Oh, hold on. It says you have been given two table artists and albums. So the artists are unique and the albums from the artists will probably be duplicates. So an artist can have multiple albums. You get the idea now? So I don't have access to this data set, but I'm just going to use logic to try and answer the question. So merge them using artist.merge, 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 albums. So artist.merge merge artists to albums on artist id.add, adjusting the validate arguments to determine which statement is false. So you can use many to many without an error since there is duplicate key in one of the tables, many to many. You're not going to get an error. You can use one-to-many without error since there is a duplicate key in the right table. You can use many-to-one without an error since there is duplicate key in the left table. You need to know which one is the left and the right. So this is the left table. This is the right table. So you can't use one-to-many without an error since there is duplicate key in the right table. So yes, we can use. So we want to determine adjusting the validate argument to determine which statement is false, which is the false statement. You can use many to one without an error since there is a duplicate key in the left table. This should be false. There's no duplicate key in the left table. Artists will always be unique list of records. Can use many to many without an error since there is a duplicate key in one of the tables. So there's a duplicate key in one of these tables here. Let's see. Oh, we nailed it. So the challenge is that you have to know that the on the left table, there can never be duplicate records because the artist record will always be unique. We have unique record of each artist, but an artist can have multiple albums. You get the idea now? So the best option is either to use many to many because the left table is going to be having the right table is going to be having duplicates, or you use one to many because the right table will surely have duplicates. Okay, that's interesting. Let's go. That's correct. This statement is false. There is a duplicate value in the artist ID column, in the albums table, which is the right table in this merge. Therefore, setting validates equal to many to one or one to one will raise an error, making this statement false. Interesting. So let's continue and see. Let's try to solve this last challenge of chapter 3. I will be done for today. So concatenate and merge to find common songs. Okay. So the senior leadership of the streaming service is requesting your help again. You are given the historical files for a popular playlist in the classical music genre in 2018 and 2019. Additionally, you are given a similar set of files for the most popular pop music genre playlist on the streaming service in 2018 and 2019. Your goal is to concatenate the respective files to make a large classical playlist table, an overall popular music table, then filter the classical music table using a semi-join to return only the most popular classical music tracks. Interesting. Let's see how to do that. So the table classic 18, classic 19, and pop 18, pop 19 have been loaded for you. Additionally, Pandas has been loaded as PD. So concatenate the classical tables vertically and the pop tables vertically. Okay, the classic table, which is this 18. So concatenate classic 18 and 19 table vertically where the index goes from 0 to n minus 1. So I'm going to set the index of values to 2 then. It's going to be pd dot concat open brackets. This one mention 2 or more tables. I'm going to use the square bracket there, comma. So we need to set the index goes from 0 to n minus 1 and save to this class 619. So that is saying ignore index, ignore underscore index equals to 2. So same concatenate pop 18 and 19 tables vertically where the index goes from 0 to n minus 1. Let's do the same thing for this. Where is going to be pop 18 and 19. So then let's run the code. Okay, let's submit that. So we got that. So with classical 18 and 19 on the left, merge it to pop 18 and 19 on the TID using an inner join. So want to merge pop 18, this classical 1819 to pop 1819 on this common column TID. Okay, I'm going to say classical 18 pd.contact. This has been done. Then I want to merge the two tables together again. So it's going to be, I'm just going to copy this. Let's copy this. So merge classical 18 and 19. Oh, I want to merge, not concat. So it's going to be dot merge. Oh, sorry. I'm going to be using something else. The merge method here is going to be classic pop. It's going to be classic 18, classical 18, 19 dot merge. That was what we've learned previously. Open brackets. I'm going to merge it to the pop 1819 on which column? On TID column. On this common column. So I want to use using dot is in filter classic 18 rows where TID is in a classic box. So I want to filter this. We are going to filters for rows where this TID is in our previous initial this classic pop. Let me see that. Using is in method. I want to use this is in method to filter for classic 1819. Classic 1819 that we just made together where TID is in classic pop. Where is that classic pop? This classic pop here. This is our merge. So this is our new. So this classic pop is from merging of this class pop 18 and 19. That's very funny. From this merging of these two tables here. So it's kind of tricky. If you don't understand what I've done in the previous lesson, you won't probably understand this line of code here. I'll just encourage you to go and start from joining on data with pandas. You understand what I'm about to do here? So it's going to be popular class. It's going to be classic 1819. Classic 1819 is in where the TID, this TID column, where the TID column is in this classic pop. Let me just look at that line of code again. It's in this classic pop, and TID also is in that, is in this row rather, or that column, that table rather. So I'm just making sure that this TID column that is in this classic 1819 table is also present in this classic pop table, which is our initial uh, table from here. Where is that classic pop? This classic pop table, that is the merge of 18, this is our 1819 and pop 1819, which comes from those line of code, those records. How would that make sense? So it's only going to be returning rows that are common to both table mentioned in this table and this table mentioned here. Let's submit that, and voila. So that's it there. So that line of code is kind of tricky sometimes. You have to understand which table you are querying for this instance. So excellent work. In this exercise, you demonstrated many of the concepts discussed in this chapter, including concatenation and semi-joins. You now have experience combining data vertically and using semi and anti-joins. Time to move on to the next chapter. So we completed this lesson in less than 30 minutes. So that's quite interesting. So these are the top what? Top the most popular classic music tracks according to our record here. So this line of this result that we got here. So interesting. So we completed chapter 3. Oh, That was a lot of lesson. So I'm not happy because I wasn't able to practice this chapter 3 in my own Jupyter notebook environment. Yeah. That's not good. But I can always refer back to the lessons. So we'll be looking at merging ordered and time series data analysis probably. So this is quite a lot. Ooh. So on this live stream, probably be spending uh three live three three different live streams to solve this record there. One, two, one, two. Let's see. All right, so thanks for staying to the end of the live stream. So if you found value in this learning journey of Python with me, do want to give this video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel, and I'll see you on the next live stream, day 37, as we continue to chapter 4 of this joining and merging data with Pandas course. Do have a wonderful rest of the day. It's Monday, get to work.